All right, let's look at a question in Newton laws of motion uh, that we have done in our previous video. So we should just have to solve some varieties of questions in this video. We have questions based on different examination bodies, Waec, Jamb, and so on. So we have them. We just have to pick them one after the other. And before we start solving this question, I have something to say. When solving questions in physics, most especially calculation questions, we write out all the parameters given so we can be guided on which formula is used, is to be used, or which approach is to be used for the question. So this is very, very vital in solving physics questions. So we get things right and done the best way. So a net force of 15 Newton. So I was told that the first question, net force of 15 Newton act upon a body of mass 3 kg for 5 seconds. So the mass of the body is 3 kg and the force acted on the body for 5 seconds. Calculate the change in speed of the body. We are meant to calculate the change in speed of the body. Change in speed or change in velocity of the body. So which formula is best used or which approach is the best used to solve this kind of question? So looking at what we are given, I can say we are using F equals mv minus u all over t. Don't forget v minus u is a change in velocity, so we can rewrite the formula as F equals m change in v over t. So now it is very easy to find them. Substitute 15 is equals to 3 change in v all over t. So then we have all over 5, t is 5. So then we have 15 times 5, which is what? 75 equals 3 change in v. So dividing both sides by 3, change in velocity of that body is going to be equals to 3, 7 is 2 is 25 meter per second square, or seconds. So that is the change in velocity of the body. As far as that question is concerned, is gone. So let's look at another question that says, a stationary object. When they say a stationary object, just have it in mind that the initial velocity is equal to 0. So a stationary object of mass 4 kg is set in motion by a net force of 50 Newton. That's question 2. A stationary object of mass 4 kg is set into motion by a force of 50 Newton. Set into motion by a force of 50 Newton. If the object attains a speed of 5 meters per second in time, calculate the value of t. So if it attains the velocity of 5 meters per second in time, t, which we don't know, so how are we going to calculate the speed of the body? Don't forget that the body starts from rest, so u will be equal to 0 meter per second. So now, using this formula, F equals ma, we can determine the acceleration of the body. And don't forget, note, acceleration equals change in velocity over time. So we can easily determine the time from here after knowing the acceleration. So the question is, can you see? So much easy. So it depends on the perspective you view it. So now, F is now 50, which is equal to mass, which is 4, times A. So dividing both sides by 4, I have A is equal to 50 over 4, which is actually 12.5 meter per second square. Better still, you leave it in a fraction down to 25 all over 2 meter per second squared. So that is the acceleration. So knowing the acceleration, we can easily find the velocity. Don't forget, A equals v minus u over t. So we can say 25 over 2 is equals to v, which is 5, minus 0 since the body started from rest, all over time t. So we have 25 over 2 equals 5 over t. Cross multiplying, I have 25t equals 10. So T will be what? 10 over 25 seconds. Or probably better still, we have 2 over 5 seconds. So in decimal, you know what the answer will be. So that is for the second question. So let's go for third question. I think I'll need to take a very different one from I would not to take the one from collision. Okay, a ball of mass 0.5 kg. That's third question. A ball of mass 0.5 kg moving at 10 meter per second. So that's the initial speed the body moves, 10 meter per second. Collide with another ball of equal mass. Collide with another ball, and the mass M2 is equal to also 0.5 kg. Collide with another ball of equal mass at rest. So meaning the velocity of the second ball U2 equals 0 meter per second. So if the two balls move off together after impact, they move off together, calculate their common velocity. So that type of collision should be inelastic. So we are going to calculate their common velocity. So using the formula M1U1 plus M2U2 equals N1 plus N2V, we are able to say M1 is 0.5, U1 times 10 plus 0.5 times 0, all equals 0.5 plus 0.5 V. So from there, this gives us 5 plus 0 equals V. Since 0.5 plus 0.5 is 1, 1 times V is V. So then the common velocity will be 5 meter per second. So with that, we have a proper solution to that question. Let's look at another question that says a bullet fired at a wooden block. Okay. Oh, incomplete. Okay, let's look at this. A machine gun of mass 5 kg. The mass of the machine gun is 5 kg. A machine gun of mass 5 kg fired a 50-gram bullet at a speed of 100 meters per second. So the mass of the bullet, let's use big M for the mass of the machine gun. Then small m or M1 equals the mass of the bullet, which is 50 grams of bullet, and fired it at a speed. As velocity of the bullet V1 equals 100 meters per second. 100 meters per second. The recoil speed of the machine gun is, we are meant to find the recoil speed of the machine gun. So, and don't forget the formula mv is equal to m1 v1 from the application of Newton's law in our previous video. So we can have m5 times v, which is the recoil velocity. Mass of the bullet 50 grams, that will be 50 over 1000, converting gram to kilogram, multiplied by v, which is what? 100. So with this, I can cancel out, and this go with this. So we have 5 v equals 5. So v is going to be equal to what? 1 meter per second. So the recoil velocity of the bullet is just 1 meter per second, as the case may be. So this 50 is divided by 1000 to clarify this point, because it's in gram. I mean to convert to kilograms. So that is the reason. So we have another question that says a rocket burns 0.1 kg of fuel each second. A rocket burns 0.1 kg of fuel. So how much kg of fuel? 0.01 kg. I mean 0.01 kg of fuel each second, and ejects it as gas with a velocity of what? 5,000 meters per second. So let that be equal to m1. So it ejects. After the combustion of the fuel, there is ejection of gas, which the speed of the gas is about 5,000 meters per second. Okay. With velocity of this, what force does the gas exert on the rocket? What force does the gas exert on the rocket? So we're looking for F. So this is just a very simple ideology. The most physics questions are just word complicating, but once you know the formula, you get it. So though we have questions that are funny. So we have the formula F equals mv. The force exerted on the rocket multiplied by the mass and also the speed of the fuel. So we can have F is equals to mass 0.01 times 5,000. So that will equally give us 1, 2. So that will be 50 Newton. 50 Newton, or probably let's confirm with the calculator. So we have 0.01 times 5,000. So that's 50. So a force of 50 Newton is exerted on the rocket. So now let's look at another question. A girl whose mass is 55 kg. A girl whose mass is 55 kg and mass of the girl is 55 kg. Whose mass is 55 kg stands on a spring weighing machine. A spring weighing machine inside the lift. Stands on a spring weighing machine inside the lift. Okay. When the lift starts to ascend, its acceleration is ascend means it's what? It moves up. When it starts to ascend, the acceleration is 2 meters per second. So acceleration of the lift is 2 meters per second squared. So what will be the reading of the machine? Take G as 10 meters per second squared. So, and what will be the machine? What will be the reading of the machine? That means the reading of the machine on which the girl is standing. So the girl is going to have a different mass on that machine. So we are going to determine that reading on the machine. So we are looking at the mass read by the machine. Let's just say M1, M2. So, and don't forget, I told you the speed of the acceleration of the lift is just 2 meters less than 2 meters per second, and it's less than that of acceleration due to gravity. So in this case, we can use the formula. The weight of the girl is going to be equals to F. Okay, let's say MA plus MG, as the case is. So we're going to add it. So we're going to have 55 times 2. Oh, that's W. We are meant to look for W, not M2. Sorry. So we have mass times acceleration, which is 2, plus 55 times 10. So that will give us, this is 110 plus 550. So adding these together, we're going to have 660 Newton. Don't forget, force or weight is measured in Newton. So we also have another question that says a bullet of mass M is fired from a gun of mass m with a velocity of v. The recoil velocity of the gun is expressed as. So what will be the recoil velocity of the gun? How can we express it in terms of formula? How can we express that in terms of formula? So the question says a bullet of mass m fired from a gun of mass bm. So the mass of the bullet is m and the mass of the gun is m. So with the velocity of v, the small velocity v, that's m1, and we also have the big velocity for the bullets. So for the gun, better still. So, and don't forget that according to the applications we have discussed, the formula we make use is mv equals m1 v1. To make v itself the formula, we are just going to add v equals m1 v1 over m. So this is the expression for the recoil velocity of the gun. Thanks for watching our YouTube video. Please subscribe to our YouTube channel. It's free. Thank you.